Alright, let's try another rational function. Okay, let's say you have x squared minus x minus 6 all over x plus 1 is greater than or equal to 0. So how would you solve something like this? Well, you might start by factoring just to make things a little bit simpler, although I don't think it's going to cancel with the bottom. So if you factor this, you get x minus 3 times x plus 2. If you don't know how I got that, well, you might want to go look it up because it's going to be pretty hard in calculus and pre-calc 12 not knowing how to factor. Alright, so x minus 3 times x plus 2 over x plus 1 is greater than or equal to 0. So remember, if you find the zeros of the function and the asymptotes, those will help you know where your equation changes from positive to negative or from negative to positive. So, where is your asymptote? Well, here you have x plus 1 as your denominator. So, if x plus 1 equals to 0, you can't have it equal to 0 or else something over 0 will be undefined, right? So x plus 1 cannot equal to 0. Therefore, x cannot equal to negative 1. And, okay, now if you solve this function being equal to 0, you'll get your zeros, which will help you also find where it switches from negative to positive, right? Because if you have a function, the points where it crosses the x-axis will be where it goes from negative to positive or vice versa. And also the points where you have asymptotes. Alright, so solve for when this equals to 0. So x minus 3 times x plus 2 over all over x plus 1 equals to 0. So solve this. Now you know if anything in your numerator equals to 0, then your entire function will be equal to 0. So if x minus 3 is equal to 0, then your function will equal to 0, or if x plus 2 is equal to 0. Oops, x plus 2. Alright. And this will give x equals to 3. This will give a solution of x equals to negative 2. Alright, so let's plot our number line now, because you have one asymptote and two zeros that you can work with now. So your 0 of negative 2 here, asymptote of negative 1, and 0 of 3. Now we're going to have to try some test points to see where it's positive. So let's test negative 3 here. Test negative 3. So negative 3, right, we're going to just plug it into this equation. Oops, that was not nice. Okay, negative 3 minus 3 times negative 3 plus 2 over negative 3 plus 1. So negative 3 plus negative 3, that's negative 6, negative 1, all over negative 2. Negative times a negative is a positive, over a negative is a negative. Now for here, let's test negative 1.5. That's a hard one. Okay. So negative 1.5 minus 3 times negative 1.5 plus 2 all over negative 1.5 plus 1. So this will give you negative 1.5 minus 3 is negative 4.5 times negative 1.5 plus 2 is 0.5 over negative 1.5 plus 1 is negative 0.5. So negative over a negative will give you a positive times a positive is a positive. Alright, so we're running out of space. Let's just delete this. If you need to review it, just go back in the video and watch it again. Okay, so here let's test 0 for this section. So 0 minus 3, 0 plus 2, all over 0 plus 1. That's just negative 3 times positive 2 all over 1, which is a negative, right? Negative. And after 3, let's test 4. So 4 minus 3, 4 plus 2, all over 4 plus 1. And that will give you 1 times 4 plus 2 is 6, all over 4 plus 1, 5. This is positive, right? Positive times a positive over a positive. Now you might have wondered, why couldn't we just have found one point and then have alternated? So if we had a negative, then we could have said this is a positive, this is a negative, and this is a positive, right? Because theoretically it switches after every zero or asymptote. Yes, it does switch after every zero and asymptote, but you have to be careful because, for example, if you have an unsimplified function and you have a non-permissible value, for example, so if you have your graph is discontinuous. Here you have a value at which it's undefined, but it doesn't actually cross the x-axis over here, right? Also similarly, well, not very similarly, but you may have functions that, for example, just touch the x-axis. Oh, that's not touching. There. Right? And here you'll have a 0, but it won't actually change the sign, right? It'll be negative, 0, and then negative again. So you have to be very careful when you're dealing if you want to just skip steps and alternate. I suggest doing test points for every section. Okay, so anyways, what are we looking for? We're looking for where the function is, let's see over here, greater than or equal to 0, correct? So you want it to be positive or equal to 0. Excuse me. Okay, so you want it to either be positive, so this section, or this section, correct? Or equal to 0. Where are they equal to 0? Well, we found them over here, right? Either at x equals 3 or x equals negative 2. So it could also be x equals negative 2 or x equals to 3. So your solution is, well, x value is between here, so between negative 2, less than or equal to x, and be careful here, only less than 1, not less than or equal to, right? Because x can't, negative 1. Only less than negative 1, because at negative 1 your function is actually undefined. So that, or x is greater than or equal to 3. So that is your answer. And that's perfectly fine. Or if you want it in interval notation, which is probably useful for calculus, you could write negative 2 with a square bracket because it's included, and negative 1 with a curly bracket, in union with, and greater than or equal to 3, since it's also equal to, it's going to be a square bracket to infinity. And that is another perfectly acceptable answer. Yes, there we go. So those can be your two answers, whichever you choose. Alright, I hope this was helpful.